today I'll be just demonstrating how to do basic marking and set out. So what we'll do as the first step, well, I'll explain what sort of tools we've got here that I'll be using today. So for set out, it's quite simple. Exercise, we need string. So where is my string? So we need string to actually mark the position of 4 pegs. We will also need measuring tape. Okay, measuring tape to measure the lengths of individual sides. We'll need plums because we need to transfer whatever we measure during the set out. We need to transfer the length from the pegs onto the profiles. So we'll need that tool as part of that process. We also need other tools that we'll be using for leveling. So that is on the fence there, water level, the most ancient way of taking levels. There is also spirit level there. We'll be using that as part of the process, and we'll prove our levels. We'll check if our levels are perfectly done using laser level, which is just there. So that's in terms of tools that we need for this exercise. Now I'll just briefly explain how the set out process and marking process works. So really what we need to know is we need to know where the pegs on the block of land are located. So at the very front, that is one peg, surveying peg. Then at the back, and that corner, and go around so the block is properly marked, and that's something that's controlled by council and local government. So before we start any real project, we need to ensure that we complete something that's called the establishment survey. And the establishment survey gives us an exact position of all pegs around the block. Once we know the location of pegs, then we need to know also where we can locate the building, because there are rules and regulations as to where the building can be built. So that is a rule that says that building line needs to be moved from the front of block of land into the block of land, and different councils will have different rules. For this exercise, we'll assume that building line is 10 meters from the front fence, and the building line is 900 millimeters from the boundary, and we'll build our garage. And dimensions for this garage are 4 meters by 6 meters. So the garage will, imaginary garage will be built parallel with the boundary. Clearance 900 millimeters, because that's the rule as well, from the fence to the garage. So what I've got here is I've already provisionally pre-positioned pegs which will mark 4 corners, and I've placed around each peg profiles or hurdles that we will put around the building once the pegs are in the right locations. Ready to go? Okay. So we've made a bit of progress with this set out and marking in St Albans. We've gone through the first stage in the process, which is set out. So as I said during the first clip, we are doing the set out for a small garage, 6 meters length, 4 meters width. This is how we do that. So the boundary is a perfectly straight line, and we are building the garage 900 millimeters from the fence. So we measured from the fence 900 meters, placed first peg in the ground, and then parallel with the first peg in the ground, we found 6 meters and 900 millimeters from the fence. That's a second peg that goes in the ground. So once you find the second peg, then using rule 3, 4, 5, we found the third corner, drive the peg, place it there, and then because this is a perfect square, 4, 6, 4, 6. This triangle that we've created on this end, we can transfer this triangle on, just watch your steps. So we can transfer this perfect triangle from that side to this side here, and that will give us one more corner here. So once we determine this corner, the last side is automatically 9. And if everything is done correctly, then diagonal, as it was in this case, diagonals for this structure must be identical. So if you measure from that corner to that corner using a piece of string or meter, and using the same piece of string or meter, then this diagonal must be identical to the first one. So if everything was done correctly, that's the first stage in the set out done. So the next part of the process is to put hurdles around the structure. I've just provisionally placed them there so they're not in my way as I was doing the set out. But now, once we finish recording, I'll put the hurdles, the right locations, the right height, and then we will transfer dimensions from pegs onto the profiles. So we'll go from pegs onto the profiles using plumb up method. So we will elevate lines onto the profiles, and we will determine the level for concrete, and the level for concrete will go like this. So to set the level for this structure, we pick the highest corner of this structure here, and the highest corner in this case is here. So we will place this level, peg for level, somewhere in this area here, okay? And we'll get the right level for this peg, and then we'll transfer this level onto the profiles and around the building. And to set the level, we'll use water level, we'll use spirit level, and we'll test it using laser level there. One step at a time. So we'll now stop recording and we'll compare. So it's level. So the level is 300 millimeters. So what we do, we mark 300 millimeters there, and then using spirit level, transfer 300 millimeters onto this peg, and using the same method, we transfer that level of 300 millimeters onto this peg. Once we transfer level onto 2 pegs, that's where you place your profile. Now it's very important that we get this 100% right, because once we set up all profiles around the building, then using plumb up method, we'll transfer lines from pegs onto profiles. And the reason why we need to transfer lines from pegs onto profiles is so we can actually dig the soil and actually place concrete and the structure exactly within the measurements for that structure. It's very important that we get these levels right. Now this first corner, I can easily transfer level from this peg onto adjoining pegs without any problems, using spirit level and proper squared piece of wood. That's not too difficult, but to transfer level from the level peg onto other corners, I need to use different methods to transfer that level. I can't do it using this here. So what we'll do today, we'll use water level, and we'll transfer the level from the measuring peg onto profile pegs. Once we transfer level onto profile pegs, we'll place all profiles onto the pegs, and we'll plumb up the structure from the pegs onto profiles. And that's where the exercise will finish for today. The person who's on the other side waits for water to come through, and once the water comes through, you measure on the peg whatever level you've got. So you measure first, and then the first person is standing in the same position, you go to transfer to second peg, then transfer to third peg, and then work around the building, getting all levels right. So once you get the first corner, oops, so it would stay like that. Water level needs to be long enough so you can reach from one diagonal to the next diagonal. So you get level on this, and just work your way around the building until you get your all levels. Yeah? So that's the process for transferring of, we've done Diana, so that's the process of transferring levels using water level. Quite simple, probably most ancient way of taking the levels, but if it's not done correctly, it can be very inaccurate. For that reason, I highly recommend use laser. And we'll illustrate what it takes to use laser. Test or prove that our measurements using water level were accurate by actually getting a small spirit level on the string itself. So if you bring the camera to the string line, so it will actually show that it is level. So it's one more way of proving that our levels are correct. So we'll do the same for the rest of the profiles. So we'll prove that the level is correct, we'll mark it, and we'll keep marking it out until everything is done, and then we'll use laser as the very last step. Alright. So the setout is done. Now we are installing profiles and hurdles. Yeah? We've set the first corner, and from the first corner we've transferred the level onto the profiles to the second corner. We have already installed profiles at the right level. Now we are down to third corner now. We'll finish it off, and once we finish the third corner, we'll go around the building, get all the profiles leveled correctly. And once we have all levels in place, using plumb up method, we will transfer strings from pegs onto profiles. So when we start digging, we've got clear or easy or full access to part of the land where we'll be actually doing the digging. So that's our progress thus far. So I'll finish these two now, and then we'll illustrate what it takes to go to plumb up exercise. Using plumb up method, we've transferred strings from the pegs onto the profiles. So what you do, you bring the scattered or plumb just about the nail, and it will tell you where the line should be. Then you pull the line and place it on the profile. You repeat the exercise across all corners, and then you bring your lines onto the profiles. So once the lines are on profiles, you establish permanent marks on profiles, because you will not touch profiles until you get out of the soil with your structure, so they need to stay in place. So what you do as the next step, you mark or put permanent profile markings on the profile. So the nail would go here, so first the line, you mark the line, you actually can write what's the purpose of that line, and this line here is the outside border of the wall brick, and I marked it with B. You can even make a permanent incision there, as long as you know what that incision means. You can mark it on the profile like that, and then you go around the whole site and mark every profile accordingly. you can and you should put on the profile all critical features for that particular wall. So the outer side of the wall, how far the brick will go, the cavity. So you can, so if the brick thickness is this much, then cavity is that much, and wood frame is this much. And for each of these, you put incision or mark on the top, and you write. So you can say cavity is here, timber, and you can put nails on the top, and you can drive the strings, so it will help the accuracy of the process. So you mark all the profiles accordingly. Once you mark all the profiles, if you were to continue with construction, you would go with marking of things on the ground using spray, for example. So you would go from strings down to the soil. So once you mark things on the soil, you can actually remove strings, and you really need to remove strings. There is no need to keep them, because you have all markings on your profiles. So you can excavate, you can do whatever you need to. You can reinstate your strings down the track when you start working on other things, such as brickwork. So you can again pull the string for bricks, which will show you where is the outer part, where is the inner part of the brick. And that's how you use profiles. So as I said, profiles stay there, but strings can be removed, and as you commence with the construction process, obviously pegs that are in the ground will be removed. Alright, so what we're doing here as the last step is we are checking the level using laser. So the laser is just at the back, sending signal to laser receiver, and when you get that continuous sound, that means that this laser receiver and the laser level are level. And to prove that all corners are level, we should get the same reading on all corners. Okay, so we should get the same reading on all corners. So go to the next one. Okay, so that shows how the laser really works. So essentially, to test the level, prove the level, you would place laser leveler in a good position where you can take measurements from all corners, and you would go around, pick the first corner. Oops. Yeah. So you would pick the first corner, hold the laser receiver in the same position, go around, and you should be able to repeat the same reading at the same height. Yeah. That proves the thing is level.